In this problem, we're taking a look at two different iPods that have two different prices associated with them, $229 for the 8 gig and $299 for the 32 gig. We know high school wants to purchase 75 of these for their STEM students, and they're willing to spend this much. We want to make sure that, well, they would like to have 32 gigabyte iPods, as many of those, but understands that you can't purchase 75 of them with their budget because he needs to make sure that these all 75 students have one. So the first thing we're going to do is, of course, we're going to start by identifying variables. So the question is, how many of each can be purchased? Well, we have, by each we mean 8 gigabyte and 32 gigabyte. So I'm going to just say let E equal number of 8 gig iPods, and then I'm going to let T for 32 equal number of 32 gigabyte iPods that we can purchase. And so now I'm going to write my constraints. So first I'm going to write them in words just to make sure I understand what they are. We know that the school can purchase, we need 75 iPods needed. And we also know that the budget is $19,000. Well, ideally, given our constraints, we want to meet these as closely as possible. And so we are. We're going to write these now as mathematical constraints. Well, the number of 8 gigs plus the number of 32 gigs need to add up to the 75. So I'm going to write E plus T equals 75. That's my mathematical way of writing this guy. That's what that translates into. Budget is $19,000. So depending on how many T's I purchase, the 32 gigs, they're each going to cost me $229. So my total cost for the 32 gig iPods is going to be $229 per iPod times the number of iPods. The 8 gigabyte iPods each cost $229. Oh, excuse me, this should be $299. These are going to be $229 times the number that I get. So here are my constraints. I'm going to write this in matrix form. I want to get AX equals B. And so my coefficient matrix is going to be, well, the coefficients here are 1 and 1. So I'll have 1, 1, 229, 299, and times the X matrix, which in this case the variables are E and T, and my matrix of solutions is going to be 19,000. So remember, to solve these guys, I'm going to write up here, to solve for the X matrix, which is this guy, there's my coefficient, there's my solution, we multiply both sides by the inverse of A, because remember, we can't divide in matrix territory. So now all I have to do is go ahead and enter these guys into my handy calculator. And so my A matrix is 1, 1. Oops, that's the wrong place for that. It has to be a 2 by 2 matrix, but I want the entries to be 1, 1, 229, and 299. And now I'm going to, for my B matrix, put in my solutions. So I come over here, pull up my solution matrix, matrix B. I'm going to make this a 2 by 1 that contains 75 and 19,000. And now I can do A inverse B. So just go ahead and fire this on in. I'm going to do A inverse times B. And I get some odd numbers, of course, because it might not be possible to purchase exactly a decimal, a whole number version of them. So this tells me that my X matrix is equal to the values 48.9 and 26.1. Okay, so that means that, remember, this is really representing the number of 8 and the number of 30 2 gigabyte iPods I want. So the question is, do I do 49 and 26 so that it adds up to 75, or do I do 48 and 27? Well, we've got to be careful here because we still have to meet budget constraints, so one of these might be over and one of these might be under. So the thing we can do to check real quick is just to make sure that our budget equation is satisfied. We can see that these both these pairs add up to 75, but now if I do 229 times the number of 8 gigabyte, so 49 of them, plus 299 times the 26 32 gigabytes. Well, that puts me under budget by $5. If I do 229 times 48 plus the 299 times 27, now I'm over budget. I'm $65 over budget. So to meet my budget constraint, I have to go with this route. That one is not going to work for me.